All right, guys, so this is week 2 of these videos. I'm excited about the lesson for today, which is U substitution. We're going to learn some strategies for finding definite integrals without a calculator, but also being able to find some of those more complex integrals now that we know our basic antiderivatives. So with U substitution, I want you guys to think about chain rule. Maybe before you watch this, you go do a couple of practice problems with chain rule if you need a little refresher on that for deriving, because U substitution is the undoing of the chain rule. And we're going to use that same U variable that we used to describe the inside function when we were doing chain rule as well. So the idea behind U substitution, what we're looking for in our integral is having some sort of a product. So remember last week when we were doing antiderivatives, we could only work with addition and subtraction. And if we saw any kind of multiplication or division, we would have to do some simplifying. Now this one here, technically I could simplify if I wanted to. I could cube this out and distribute everything. Or we can use this process of U substitution. So here are the steps for that, and I have several examples that we're going to go through today. So the first step is to define U, and just like we defined U in the chain rule when we were deriving, we're again looking for where is that inside function. If you remember, when we did the chain rule for deriving, the inside function got put back into the derivative, so we expect to still be able to see it in our integral. And so we can see here that this x squared minus 9 appears to be inside of another function. So I'm going to define that as u. Now the other piece that we need is the derivative of u. That was also a piece that we looked for, or that we created when we were doing chain rule. But this time I'm going to do my notation a little bit different. So when I derive u, I'm going to end up with du dx, right? I'm deriving u in terms of x. And when I derive u in terms of x, I get 2x, because the derivative of x squared is 2x, and then the derivative of negative 9 is 0. Now, one last step here that's a little bit different from what we ever did with chain rule is I'm going to move the dx to the other side. So I know that du is equal to 2x dx. And here's the beautiful thing that we're looking for. 2x dx is in my integral, right? We see it, 2x dx. So we get to replace 2x dx with du. Just all of that mess becomes du. And then we're going to go ahead and replace this x squared minus 9 with u. And so what I have when I do those substitutions, the u substitution, I end up with u to the third power du. And this integral is much prettier, much easier for us to look at. And we have a rule for this that we can follow. So I'm going to go ahead and add 1 to the exponent and then divide by that new number, and I come up with u to the fourth over 4 plus c. Now, just like in the chain rule, my final step, of course, is to put things back in terms of the variables that they were originally in. And so this is going to be x squared minus 9 to the fourth power divided by 4 plus c. So let's take a look at another example. And as we progress, I'm going to make these examples a little more challenging so that you're prepared for anything that you may see. So as you're looking at this one here, I first want to note that this is a cubed root, so don't confuse that with an exponent on the x, but we're looking at a cubed root here. And as I did all this talking, hopefully you were able to identify that our inside function is this 1 minus x squared, because that's on the inside of the cubed root. So we're going to go ahead and define u as 1 minus x squared. My next step then is to find the derivative of u. And so I'm going to use my notation of du dx, which says that I'm deriving u in terms of x. And I end up with negative 2x dx. Oh, sorry, negative 2x. Hang on. That dx gets moved to the other side. I'm getting ahead of myself here. So du is equal to negative 2x dx. Now looking at this, you might notice that we don't have negative 2x dx. We have an x, we have a dx, but then we have a 5. So we're just going to do a little bit of rearranging here to make this work for us. And the first thing I'm going to do is I'm going to divide by negative 2 on both sides. okay, because this tells me that negative 1/2 du is equal to x dx. Now this negative 1, well, let's go ahead and substitute this in so that we can see what we're doing here. So 5 stays there. My x dx is going to get substituted with negative 1/2 du. So I'm going to go ahead and put that at the back here, negative 1/2 du. And then I substituted the inside of this cubed root with just a u. Okay. Remember with integrals, we learned about the property that constants get to move in front of the integral, and that really helps us because then we don't have to mess with them. We don't have to do any kind of extra math or anything. So the 5 is going to move out in the front, and the negative 1/2 is going to move out in front. Now I'm going to multiply those together. So I'm going to move out a negative 5 over 2, and then I'm left with the cubed root of u du. So it's okay if our numbers, just the constants, don't match up exactly, because we can always move those constants in front of the integral before we do any kind of our anti-deriving. Okay, from here I want to write this cube root as an exponent so that I can apply the power rule. So I have u to the 1/3 du. So when I add 1 to this, I'm actually adding a 3 over 3 because I need a common denominator here. And so that's going to be u to the 4/3 divided by 4/3. Don't forget that this is being multiplied to a negative 5/2, so you just have to make sure that you bring that down as you do the antiderivative. And then we're just going to clean this up a little. So when I divide by this fraction here, I'm actually multiplying by the reciprocal. So I'm multiplying by 3/4 u to the 4/3 plus c. And then I'm going to go ahead and multiply negative 5/2 and 3/4. And so my final answer would be negative 15 over 8 u, oh, I'm sorry, got to put my x's back. So negative 15 over 8, 1 minus x squared to the 4/3 plus c. And that right there would be the antiderivative to that problem. So just to reiterate, those numbers, if it comes out once you derive that your numbers here don't actually match inside of your integral, it's okay. You're just going to move it over with the du and substitute it that way, and then you can move the constant in front of the integral. The next example I have for you here, take a look at this and see if you can identify the u. So the inside function that we see here is the 1 minus x squared that is inside of the square root on the bottom. Okay. When I derive u, I get du dx is equal to negative 2x. And then I move that dx to the other side. So I have du equals negative 2x dx. And again, we see that we're in a situation here where we don't have a negative 2. We have an x dx to replace, but not that negative 2. So I'm going to divide both sides by negative 2, so that negative 1/2 du is equal to x dx. Now when I go to do my substitution, the x dx is going to be replaced with negative 1/2 du. And then in the denominator here, I have the square root of u. We want to clean this up a little bit before we try and do any anti-deriving. The negative 1/2 is going to move in front of the integral. And with the square root of u in the denominator, I'm going to move that up and write it as an exponent. So when I move it up, it becomes a negative exponent. So I have u to the negative 1/2 du. Now I apply my power rule. So I'm going to add 1, which really means I'm adding 2 over 2. I need those common denominators. And so I have negative 1/2 times u to the 1/2 divided by 1/2. And then there's a plus c at the end of that. And then when I'm dividing fractions, that means I'm multiplying by the reciprocal. So I'm multiplying by 2 over 1 u to the 1/2. And I can see here that these are going to simplify. And so I'm left with a negative 1 minus x squared to the 1/2 plus c. You may also see this written as the square root, 1 minus x squared plus c. Keep in mind that that plus c is not outside of the square, or is not inside the square root. Okay, so that's on the outside. So either one of those would be acceptable. Make sure you're familiar with those equivalent expressions in case you're dealing with a multiple choice question. Okay, next one here, we have to have some trig, otherwise a lesson in calculus is not complete. So this one, again, we're looking for that inside function. We can see that the inside function is inside of sine, and so u is going to be equal to x to the fourth. I derive u, so du dx is equal to 4x to the third. And then I multiply by dx on both sides, so I have du is equal to 4x to the third dx. And lucky us, this one here comes out exactly as we want it, so we're just going to be able to substitute this like we see it. So now we have sine of u du. Okay, u was replaced, or u replaced x to the fourth, and du replaced the 4x to the third dx. So now I find the antiderivative of sine of u. If you're still working on these, remember to take a look at your cheat sheet, and this is going to give me negative cosine of u plus c. And then my final step is just to substitute that u back in. So cosine of x to the fourth plus c. One last example here, again, we're looking at a trig function. So this one, looking for that inside function, we should be able to recognize when we have an exponent here, this means that we have cosine of x to the third. So my inside function is that cosine of x. And so when I derive u, I get negative sine of x. And when I move the dx to the other side, I get du equals negative sine of x dx. Now we have a positive sine of x dx, so that just means we need to divide by a negative 1 on both sides. So negative du is equal to sine of x dx. So as I do all of my replacing here, the sine of x dx is going to be replaced with a negative du. And then that cosine of x gets replaced with a u. So I have 1 over u to the third. The negative I'm going to move in front of my integral. And I'm going to move this exponent up to the top so I can apply the power rule. So this is going to become u to the negative third du. Then I add 1 to the exponent, which is going to give me u to the negative 2 divided by negative 2 plus c. My negatives here, because I've got 2 of them, they're going to cancel out and become a positive, and I'm going to replace u again. So I have cosine of x to the negative 2 over 2 plus c. And since this is a negative exponent, I'm going to go ahead and simplify this one step further by writing this as 1 over 2 cosine squared x plus c. Okay, so if you're looking for more practice problems on this, there's plenty of them in the textbook. If you go to pages 306, 307, there's a whole bunch of options there, numbers 11 through 37 odd, and then numbers 47 through 59 odd. Of course, if you have any questions about this, feel free to reach out. Hopefully this was helpful for you guys.